Welcome to today's webinar, How the University of Oklahoma Improved Network Security and Achieved Greater Visibility at Nearly 50% CAPEX Savings. My name is Sharon Fitzpatrick, and I will be your host for today's webinar. Joining us is Aaron Balio, Managing Director, Security Operations and Architecture at the University of Oklahoma, and Fazl Khan, Technical Solutions Architect at Big Switch. As we go through the presentation, please feel free to ask questions using the Q&A box on your webinar dashboard. If you're watching this as a recording or as a rebroadcast and you have questions about this topic or any of our upcoming topics, just email us at info@bigswitch.com. We've also provided you with handouts for today's session. You can download them from the Handouts tab on your dashboard or email us to get your own copy. We have a full agenda for today, so let's get started. Cybersecurity is a hot topic because of the data breaches and challenges we hear about every day. This is not just limited to higher education. In a recent EDUCAUSE survey of higher ed IT executives, information security is the top issue for the third year in a row. This is what they focus on or will be focusing on in 2018 because of their diverse community of students, faculty, and staff, and the complexity of where these attacks might come from. These trends have complicated efforts to deliver effective and rapid responses to the complexity of security threats that they receive from all corners of the world. One of the keys to successfully managing these threats is information. Knowing the impact of the threats across their infrastructure. Having the analytic data from their entire open network enables universities like OU to respond and scale their responses to thwart these threats. The Big 12 schools, including OU, have been recognized as cybersecurity leaders across all D1 schools. But there is still room for growth. With the increasing complexity of technology, architecture, and data offering new security challenges, the best is ahead. What I'd like to do to start us off is help me understand a little bit about where you are in your IT efforts. So feel free to share that information with us. And I'm going to ask our two speakers, what do you think the answers might be?
Thank you, Sharon. This is Faisal. I think from my perspective, the complexity of security threats and also this increasing complexity of technology, architecture, and data, that kind of stands out for me.
Aaron, how about you?
Well, it's going to be hard to say. I think complexity definitely, and it seems every year it kind of evolves on what's the threat of the day. But I think a lot more institutions are now challenged with trying to have this data-driven decision-making, where they're sending data and, especially when it comes down to budgets and retention, I think that's going to take a front seat compared to the rest of these.
Yeah, I definitely think you're right. I think that the complexity of the technology seems to be really high on the list, and that so far is where our audience is voting. That is 100% at this point. Let's give it another 4 or 5 seconds and we will share the results. But I think it's really fascinating to see that everyone does seem to be addressing the same things, and maybe there needs to be some commonality in how they check all the boxes to deal with some of this. I'm going to close the poll and I'm going to share the results. And so what you'll see is that we do have a significant advantage as far as what people are going to be saying. There's complexity of security threats, complexity of technology has gone down to 86%, but data-driven decision-making, so they're the top 3 at OU. This is led by Aaron Balio, who is the Managing Director of Security Operations and Architecture at OU. They have been using Big Mon Out-of-Band for over 2 years and have recently added our new analytics node and recorder node to their toolset. Today, Aaron and Basel Khan, the BSN technical solution architect who's worked with Aaron at OU to implement this, is going to also be joining us. Aaron, let's start with you. Tell us, how did OU improve network security and achieve greater visibility at nearly 50% CAPEX savings?
Thanks, Sharon. I appreciate the introduction. I've been here with the university for about 3 years, and I manage the security operations team and our engineering team. And prior to this life, I did about 11 years with the Department of Defense. So it was a pretty interesting change switching over to the education environment, whereas the first was, our mission was to keep our secrets, and here at education, we're trying to give them all away. So it's an interesting balance. And talking about the quiz we just took, we're obviously in the same bucket, and we're experiencing the same challenges. And a couple years ago, when we started looking at Big Switch, we were at this point where we really needed to expand our monitoring capabilities and how we were going to send data to our tool sets. We were moving locations into a more formal data center environment, and then challenges just continue to grow and change, and every year, like I said, we seem to experience something new. So we had another vendor as our packet broker technology, and we were looking at refreshing it, and we're running quickly out of ports, running quickly out of licensing capabilities. And so to be able to really build out where we wanted to go with Elasticsearch and our log aggregation, and where we were placing taps and spans and whatnot, we recognized the need to move in a different direction that was not only something that would expand with us, but would meet our current needs at the time. So this really just kind of set the stage for the next couple slides. A lot of higher ed institutions have experienced a breach, and I'll say in the last 3 years we've had two, not system-wide, but we have had two breaches. And so if you were to ask the students, I doubt most of them would have even known unless they were directly involved. So it's interesting where we try to be upfront and communicate what's happening on the network and in security, but it seems to fall, or maybe that they don't care, or they're not receiving the right messages. So it's interesting, these statistics, and how we were experiencing the exact same things and trying to reach our constituents, whether it's because of malware or phishing or denial of service. Of those three, phishing is probably the highest concern for us, and something we experience the most often, which results in compromised accounts. So that's kind of where we are, and how we looked to Big Switch and our packet broker technology to help us out. So because of the volume, because of the criticality of some of the systems, we need to be able to react quickly. We see all kinds of threats coming in, but like I said, phishing and compromised accounts are probably the number one problem we face here. We wanted to expand fairly dramatically our monitoring capabilities and how much data we could collect and move around. And so we were looking at a new packet broker solution, and we needed all of those things to be able to quickly help us identify and analyze that data that were coming in. And scale was also going to be key, not just because our tool sets were growing, but because we're going from 10 gig links to 100 gig links. Looking ahead, not only do we need something cheaper that was going to meet our needs, but it was going to be able to expand with us over time and where we wanted to go with it. Vulnerabilities. I didn't want to dwell too much on this, but just to kind of highlight that, because higher ed tends to be a more open environment, that we tend to experience things a lot of other enterprises don't. and I probably don't need to reiterate that with this community, but this is just a sampling of some of the things that we have to deal with. So, it's interesting. We have a very decentralized IT system here. So central IT is a fee-for-service model, and if a department or college decides that they don't want to, pay central IT to do their IT, they can go out and do it. So in that case where that department experiences a breach, they are directly liable, for handling that, even though they're going to reach out to, say, the central security team to ask for assistance, or wherever we can hop in. But it becomes very difficult. Some of those lines are really blurry on what we can and can't do, just because of that decentralized nature and liabilities, and where we do have visibility and where we don't. So we try to do as much as we can at the network layer. Sometimes these departments have a firewall, and we don't really actually know what happens back there. So it definitely makes for a unique challenge, again, that I don't think a lot of other enterprises experience. But then we have cases where it is definitely a systemic issue. February 2016, we had our first encounter with Locky ransomware, and it really became a pretty critical issue across the campus, where we had to stop allowing certain file types to be sent over email, and we were seeing students forwarding those emails on to like big distribution groups, and so it was quickly spinning out of control. Now, we were fortunate because we had a very small amount of systems actually affected, but it was just one of those where we had to react quickly, and it was campus-wide, and our constituents were actually exacerbating the problem. So it was really interesting. So some of the things we've done, obviously, talking about the big switch stuff, we changed our packet broker technology. We've set up a student-driven SOC to be able to quickly respond and detect issues that we can now really visualize with all of this data coming into one place in our Elasticsearch cluster. We've started building, some analytics and dashboards and alerting to really help us get to a state where, hey, these students can quickly react or escalate an issue, especially on the compromised credential side. We've also hired a full-time person to just do training and awareness, and so she helps coordinate our notifications to campus or departments. She's done a lot for local departmental training, as well as kind of generalized faculty and staff training. Our participation in the cybersecurity training has gone up like 200-300% every year. And we've done some other things just to really include campus on cybersecurity awareness. So, as we've operationalized a lot of things, we've also been able to I guess, attack from the training and awareness side to really get the word out to our student community, especially, but also faculty and staff, that, hey, we're here, we're concerned about security, and you should be too.
So as part of your student-driven security operations center, do you try and do a lot in anticipation? You're hearing there's an industry or some sort of phishing that's coming. Do you use that to then go out and communicate to your audience?
We do, especially when it comes to vulnerabilities. An obvious one that jumped out in my mind when you asked the question was the Intel chips, the vulnerability that just came out recently, and we teed up information that we sent out to the whole community saying, hey, this is something you need to be looking out for. You could be susceptible to a compromise. Definitely, our faculty and staff are alerted to like IRS fraud type of emails, and to not send 4s or W2s in the clears through email and things like that. So we do try to be topical in our communication with our constituents. This talks more to some of the other features that Big Switch has to offer. So just as a brief summary, the packet broker, it resides on a SDN type, a software-defined networking, and we're going to get into that a little bit later. But that really collects our traffic data at our edge, and like I said, we're going to 100 gig here soon, and all of that is filtered back to our data center, where we can start feeding not only our open source tools like Elasticsearch, but some commercial products we have as well. So with the packet filtering, that would allow us to deduplicate, which ultimately would reduce our hardware costs across our ELK stack. That way we're not having to send quite as much data. We don't need to build out quite as much. And obviously we're not going to fill up 100 gig overnight, but as that continues to grow and expand, we won't have to invest quite so much on hardware costs as that continues to grow. And then it's just more efficient. Packet slicing, our radar research labs on our research campus, National Weather Center, send large, elephant flows, large research, weather data, and that kind of stuff across the country, and that it does traverse our network. So, we want to see that, but if we could cut those payloads, that would certainly help, again, just increase our efficiency and our ability to save on hardware costs. Another thing that we're trying to do with our networking team, as we partner with them a lot of things, is start doing flow captures. In security, we've been using Bro for the last couple of years to do that flow analysis on metadata, but our networking team really wants to see the actual flow data in those tuples. So as we build this out, it's something that we can work with them to capture those flows. Some of our legacy networking components don't actually generate the flow data that they need. So this makes a good central point for either the flow generation or capture, just so we can again send it to another set of tools to be able to quickly identify traffic patterns and application stability and how those are working, and then obviously the security layer on top of that. And then the third component is what they call the analytics node, and this has been a huge advantage just to be able to see those categories of data. If you want to look at ports or protocols, for example, I put DNS there. We can see DNS as a total percentage of our traffic, which was a fairly significant number. And then, as we have purchased things like OpenDNS, we want to know, what our top DNS talkers are and who's not using, our OpenDNS platform to, for that security layer. Are they using one of our other DNS servers? They're using Google, or so we kind of quickly identify those areas and start making inquiries about what's going on there. The other really interesting thing has just been anomalies in traffic. So are we seeing what we expect to see? Are basically saying is our taps really collecting all the data? Did we see a spike in activity or just general trends in traffic usage, say over a school year? We can start to aggregate over time and find out what the ebbs and flows are. And then again, just that general analysis, especially with our network team, to talk, where are our users going the most? How can we optimize those connections? Cloud apps specifically is of interest as we continue to grow there, and as that data-driven decision making starts to become a bigger issue. Where are we sending data? Is it controlled? We have all these organizations trying to build or leverage these data lakes and trying to get information from PeopleSoft and Banner, and they're sending it all over the place. This really helps us kind of figure out the who, what, and where of where the data is going, and then any other interesting traffic patterns that you could define a search for. We can do that all in the analytics nodes. That's been of tremendous value as well. So this is just kind of a case study of what we're able to do. And when I said focused on phishing and compromised accounts, so this was something that one of our analysts had come up with that was a really good use case, and it worked pretty well. So we are alerted to some kind of phishing attack, right? Comes in, it either hits one of us or someone forwards it to us and says, hey, I just got this. We look for the URLs and we do a normal triage, but with, say, the packet recorder from Big Switch, so we can look for and bro who actually posted to that website. So, it's one thing to open the email, it's another thing to click on the site, but we can actually determine who posted information to that site. So did they post, say, their username and password? We can find that session in the packet recorder, replay it, and look at, did they send, their legitimate credentials to that website. So then at that point, we made a determination yes or no, and then through an API, we can, either create an incident in our case management tool or lock the account. There's a lot of things that we can do to automate this whole process, and ultimately that remediation would be to lock the account. So this was a really cool use case that we were able to develop, kind of using a lot of different Big Switch components. And this is really kind of the summary. We were expanding our Bro and Elasticsearch capabilities. We have some commercial tools that also need to feed or get fed by our packet brokers, and it really just has enhanced that whole capability. I don't know if you've used some of the other packet broker vendors out there, but UIs can be fairly clunky. It's hard to set up policy groups where you're only sending certain IP addresses or say subnets to different tool sets, and this was really easy. It's a very low learning curve, and so we were really quickly able to quadruple the amount of ports that we had available to us. We were able to move data across campus really easy, and so the whole combination of all these tools, we were able to do it for, it says 50% less. It was probably more than that compared to what we were going to spend upgrading our legacy solution. So it was significant cost saving and a huge increase in what we were able to do with that tool set.
Thank you so much. I think people are really interested in kind of some ideas you've had. Is it the hardware that's driving the savings? What other things go into that as well?
Yeah, a lot of it was hardware. We saved about half as much as we were going to spend, a little bit more than half of what we would have spent, upgrading to the next platform of our old packet broker, and we were still going to be short the ports we really wanted to get the coverage we needed. So with the hardware savings, we were able to get the 48 port boxes and a bunch of them, expand, be able to put them all over campus, and for a lot less than what we would have done upgrading our older gear.
Thank you so much, Aaron. I think this has been great. We have some questions we'll kind of add to the list towards the Q&A, but at this time I'd like to introduce Basel Khan, our Technical Solutions Architect.
Thank you, Sharon. So before I start off, I really want to thank Aaron and the OU Network team for their partnership and, of course, their confidence with Big Switch technology.
Well, thanks for having us. I mean, it's like I said, I don't think that the benefit could be overstated any further than we have. It's been one of the best investments we've had in the last couple of years.
We appreciate that. Thank you. So I will be covering Big Monitoring Fabric, and essentially I'm going to take you on a journey from the perspective of a customer as to how you go from legacy network, what are the challenges, and then eventually you get to a happy place, the SDN Big Monitoring Fabric place. And I think Aaron will probably relate to this quite a bit. So when we look at the legacy network challenges, in order to give you some perspective around what those challenges are, customers like OU and others are facing with the challenges. What they are is, it's a 1990s CLI. It's a command line that you are sort of stuck with. It's a box by box networking. The entire network is complex to manage. In the old network architecture, typically what happens is you've got a lot of protocols to manage between these boxes, right? It's all manual work. Your speed is slow, you can hardly innovate, and you cannot move fast. And to top this whole thing off, the hardware that you're dealing with is proprietary. So essentially, you get absolutely no choice in terms of what hardware you want to run underneath. So welcome to cloud native networking with Big Switch Networks, where you have single pane of glass, an interface that gives you a complete control over your entire fabric, giving the control back in your hands to innovate faster. It gives you complete freedom to run fast. It eliminates complexity associated with box by box networking. And of course, you have the freedom to choose the hardware vendor that suits your needs and your price point. So how do we do this? At Big Switch, we have taken the approach of innovation driven by the modern networking principles that are embraced by these big names that you see up there. At the heart of all of this, you have this open networking hardware portfolio. That this is a choice that is, with the customer to pick and choose what fits their price point, what fits their architecture. The end result is, of course, the customers are getting the, this hardware at a very low CAPEX. Of course, the second big pillar is the SDN control, driven by the controller that I'm going to give you a little bit more detail on. The controller essentially gives you this operational simplicity. It provides you network automation and brings your overall operational expense to a very low value. And the reason is because when you are not doing box by box networking, you are managing your entire fabric through a controller, you have one entity to deal with. So your overall time to manage, operate your network is going to be reduced to more than half. Of course, the third big pillar is the concept of pods. The fabric have to be pod based so you can scale out however way your design is. If you have a small design or if you have a very large network, you should be able to scale out linearly, right? This fits in really nicely in any greenfield or even brownfield deployments. And the innovation and velocity that the SDN controller gives you is sort of unmatched, something that you cannot expect from a legacy network. So as you just heard from Aaron, OU has been using the big monitoring fabric architecture in their network. Before I provide you an overview of what that is, let's first see what we need, why we need the big monitoring fabric to begin with, right? So we all know that every organization, there has been a massive increase in network and application traffic. It's sort of the same trend everywhere you look at, in different verticals. Visibility gaps have always led to security vulnerabilities. Hopefully everybody agrees to that. Therefore, you have the need for all of these tools. So you have a sprawl of these, application performance monitoring tools, network performance monitoring tools. You've got to have a lot of security tools that are monitoring what's going on in your network. And to add to this list, you need a traffic analysis tool and probably recorder as well in almost all cases, because you should be able to go back in time and see what was the interesting traffic. So as we get into this sprawl of tools, from on the network side, the legacy network just doesn't cut it. The legacy network itself, it's highly manual. There is a trend here where you have a lot of taps and spans that you are sort of connecting one off, right? You have these provision change orders. whereby you take a span and you connect to a box, and now you are stuck with that one box to be able to deliver your tools. The idea is that sharing is just not possible in this type of a legacy architecture. Resource utilization is, of course, very much suboptimal. You've got bandwidth mismatches, between your tabs and to your tools. And of course, there are architectural challenges. There's tool silos. People, teams cannot really share tools. We all know that the network packet brokers costs are also very expensive, of course. So when you kind of have to grow, you have to design this with another box, and then off you go, right? So overall, the experience, in terms of the legacy monitoring architecture is not good. So this is where big monitoring solution sort of comes into play. It's of course a controller-based architecture, and my next slide is going to give you more details. But the idea is that you've got your production network, and everything connects to this uniform, single, logical network packet broker, and your tools are also all centralized. So, the cybersecurity demands that Aaron was talking about. There is a solution, right, for that, with this big monitoring fabric where you can monitor every flow, every workload, and from every location. You can send packets to any and every tool on any media, fiber, copper, and connect it to any speeds, 1 gig, 10 gig, all the way to 100 gig. The controller sort of is going to filter your traffic to get you out of this mismatch, and load balancing. It does a lot of things. So now let's talk about the out-of-band network solution, which is the architecture that OU have implemented. So, at a very basic, as I was telling you earlier, that from your network, whether it's a data center network or campus network, you've got a bunch of your tabs and span traffic that is terminating on this one uniform fabric, built with a number of open networking hardware, call it bright box or white box, a choice that is, something that the customer picks, eventually builds this fabric, however small or large. Of course, right here, the fabric is shown to be very big. It could be as small as a single switch, or it could be as large as hundreds of switches. The idea is, if it's a single switch or 2-tier or 3-tier architecture, as you grow, you can build this in a pod size, right? So here in this example, we are showing a bunch of leaf switches and then a bunch of spine switches, call it core switches. And in this picture, what you're seeing is tabs and spans are all terminating onto these switches. We call them big monitoring fabric switches. So BMF out-of-band switches. The tools are also all centralized. So again, here it kind of shows a picture where campus and network traffic is all centralized on some switches, and tools are centralized on another set of switches. But essentially, this can all be anywhere, right? So we really don't bound you to have tools and the data traffic be terminated on selected switches. It could all be within this fabric. As I said, this is a fabric-based approach. So resources can be anywhere. Now, this fabric is controlled by something we call as big monitoring fabric controller. So you see there are 2 BMF controllers. These are physical or virtual controllers. And when you have a controller, essentially you eliminate the need to manage these switches individually. Your single pane of glass is going to be your controller, whether you are logging into the controller through GUI or through command line. This is where you log in and you manage your entire fabric. So once we connect our production network and our tools, we could do a number of things. This fabric with this controller is capable of doing a lot of filtering, right? So we utilize the existing ASICs on these switches to be able to filter traffic. So we can go do a lookup of about 128 bytes into the packet and make decisions, filter traffic as the traffic flows from production to your tools. But then there are scenarios where you have to look deeper into the packet and do a lot of manipulation on the packets before they are delivered to the tools. So things like packet deduplication, packet slicing, packet stripping or masking, even things like net flow generation, that all is done on this big monitoring service node. Of course, you can cluster these if you want to, based on your requirements. And the idea here is that as the packets are flowing from left to right, we send the traffic to these service node appliances, one or many, and essentially utilize these advanced capabilities. Packets get manipulated, it comes back to the fabric, and then in a very automated way, controller then delivers it to where it's needed. So you probably can see here, the idea here is to deliver packets only where it is needed and exactly what's needed. So if we can, eliminate the unwanted packets, whether we do deduplication or slice the packets, we only deliver what's needed on our tools, which of course means that our utilization of these expensive tools is going to go up, right? And so, if we need to say load balance on these tools, we can have the controller with these switches load balance the traffic to multiple tools. We can create, of course, policies on the controller, a policy that can, deliver tools to one team, another policy to deliver another team. And you've got this controller that's managing the entire monitoring infrastructure and a centralized way to handle policy creation. So a few other aspects of this fabric is that this is not just confined within the boundaries of your data center. Many times you want to monitor your traffic in your remote locations, right? So if you have smaller sites, the idea here is to be able to expand this fabric out to your branches, right? So just putting a few more white boxes or bright boxes in your remote locations, you can create this GRE tunnels and bring your traffic in the data center, or have that monitoring traffic be delivered to the tools in your branches itself. So we give different options, again, from the same controller. The other aspect of this fabric is the big monitoring recorder node, which is what Aaron was mentioning earlier. As the packets are flowing on this network, how nice would it be if we can record the packets? Hopefully not all of them, but things that interest us, we should be able to record those packets, and being able to query and replay those packets. And I will talk a slightly more detail on the recorder node. But the idea here is that the service node and recorder node are all connected to the same fabric. Of course, they are all discovered automatically. They are managed by the controller, so you don't have to individually manage them. And then the big monitoring analytics node is also part of this, which of course is an entity that provides the analytics on the overall packets as seen on this network. So again, I will go get to more details on this aspect as well. Lastly, this fabric is also extended out into your public cloud. So say if you have Azure or your Amazon workloads, those are also capable to be folded into this overall BMF architecture. So Aaron, I'm kind of curious, how has an SDN-based controller changed how you manage and operate your network?
Yeah, I think that kind of goes to my point about the really low, I guess, training requirements. Just we were able to get ramped up really quickly because you just plug it in and it's auto sensing, and you can really get going and hit the ground running. There was, because it's auto sensing and it's got a really great UI, we don't have a lot of training requirements for for any of our staff members. And looking in the future, there's it's really set and forget. It's easy to expand because it's all plug and play. So for us, it's been a big benefit in that respect. Just to be able to get going and get running without a lot of training, and we still get all the same switching capabilities as any other traditional switch, regardless of manufacturer. There's not a lot of command line, right? You have to memorize, and then you can still do a lot, at a port level, and moving data and packets around. It's been really great.
Awesome. So really, what you're talking about is this one big switch architecture that I wanted to explain very quickly. So sometimes the SDN approach, this controller-based approach, gets a bit confusing, right? But it's really easy if you kind of understand it from the traditional aspect. Everybody is familiar with these chassis-based approach, where you have supervisors, line cards, and of course service cards, right? And if you kind of take that analogy and sort of apply it to the big monitoring fabric, what you will see is that at the heart of this is essentially very much similar, right? Meaning the supervisors are nothing but this big mon controllers, right? It's really playing that type of a architecture. Your spine switches, are essentially nothing but the backplane, as you have in a standalone chassis, and then these edge switches or leaf switches are just like line cards, right? Of course, without the need for the package to go up to the supervisor or the controller. The packets are of course switched locally, but this whole architecture of line cards and service cards all acting like edge switches in this overall controller, really that's the best aspect of this. The whole ease of use, where you are no longer managing however number of this components, whether switches, service node, analytics node, recorder. You're not managing them individually. You are all doing it through the single controller. So I want to spend just a little bit more time on the analytics and recorder, because that's an essential component that Aaron was talking about earlier, something that OU is using today, right? And so analytics node is something which is very critical, right? So as the name says, this provides the deeper level analytics as to what's going on your network, right? And so sometimes customers come up with basic requirements, and I've sort of captured those here. Like, everybody wants to know, what are the apps that are flowing on the network. So app identification becomes critical. Everybody wants to get deeper visibility into their flows. They want to be able to detect anomalies. And they want to get to some sort of baseline in terms of their network performance, right? So these are some critical needs for analytics, and really essentially the best aspect of the analytics has to be coupled with programmability. You have to be able to, with the help of analytics, figure out the interesting thing. You have to be able to detect and then capture. So Aaron, again, can you share some of the requirements that you have in terms of analytics? I know there's some other tools that you are using, of course, for analytics, but how are some of these analytics that are inherently built onto the controller architecture, kind of fits into your needs?
Yeah, I mean, obviously everyone wants more insight, right? And I don't want to confuse analytics with metrics, right? We're not really trying to measure. We're just trying to get some analysis and maybe some cause and effect. So for us, some of our key insights that we were looking for is kind of what I alluded to earlier, right? Our top talkers. When we implement something new, like OpenDNS, or I guess it's called Umbrella now, but we want to see who's not using those tools and why. Is that just a configuration thing? Are people, purposefully, reaching out to other DNS servers? So that's kind of the insight we're looking for. Another thing actually just come up on the education ISAC is this concept of DMCA violations and BitTorrent activity and peer-to-peer networking. And if you're not monitoring that, you're not seeing all your traffic. Could I say, well, how much bandwidth are we dedicating to BitTorrent traffic? Is that something I can block, or is it something that we should allow? It just adds an element of insight, when you're decision making that helps inform that decision. And so that's the kind of the things that we're looking for, are these data points that help us make better informed decisions about our monitoring. What are we monitoring? What can we see, and what can't we see, and that kind of, what kind of data are we going to send to our analytics nodes, or our security tool sets? So those were really our key requirements. Is again, not metrics about measuring the traffic, but what other kind of insight can we get out of it?
Yeah, so big monitoring analytics node really does that. I mean, it's like a scale out architecture where you can see like these historical time-based dashboards. But the idea is really that Big Mon Analytics receive this metadata on these control packets, DHCP, DNS, LLDP, CDP, ARP, and there's many, right, from these switches, and give you these performance views, these nice pie charts and graphs. The idea is for you to be able to get deeper level security visibility. Like, I mean, there's so many use cases, rogue DSCP, rogue DNS servers, how much traffic is going on to the DNS side of things, and automatic alerting on a lot of traffic makes, interface utilization. It also, by the way, is an excellent tool for SFlow and NetFlow collection, right? And so, it's like a one-stop shop where you sort of go in, of course, and look at these statistics and capacity. You do capacity planning. It's really a tool that kind of gives you this deeper visibility. I mean, there are just so many use cases for it. Some things that come to my mind is like, some customers are, kind of use this for anomaly behavior reproduction. So, for example, like ICMP, where you're detecting ping of death style attacks. You can kind of this can really help in that aspect. Sometimes you are looking to isolate reasons for poor performance. So connection tracking, that's a great one where you can go and drill down deeper, or identify possible security issues. Traffic from unknown location, identify source and destinations and protocols. What is really happening on the network. Or just additional packet detail. You can get to that level as well to gain further behavior and insights. So moving on to the packet capture, and packet capture essentially is where again some requirements here, right? You should be able to capture flows for offline analytics, right? Preferably 1 week to few months of traffic. It of course is needed for deeper level troubleshooting and application performance. There's a lot of security sensitive flows that need that type of analysis. So the packet capture, the Big Mon recorder node essentially is a tool that it's an appliance, of course, x86 based appliance. It has 160 terabits of hard disk storage. Today, 1 gig of 110 gig interface to capture packets. It's essentially a high performance packet recording, querying, and replay type capability tool. That you can sort of utilize in your network to replay where interesting traffic that can help you come to some conclusion as to what was happening at the time of an issue in the network. So I know, Aaron, earlier you were talking about this phishing attack and how BSN Recorder has helped you a lot. You tell me how important it is for you to sort of go back in time and look at actual packets in your network. You know, again, it doesn't have to be about phishing, but just this aspect of, you know, going back in time. I personally think that's just awesome.
Yeah, well, it's a huge benefit, right? Because, you know, I spent a lot of time talking about bro and syslogs, and all of that's great to get that metadata on the sessions and whatnot. But, you know, the piece that was missing, right, is I can't actually go back and see the packet. I can't replay it. I can't do anything. Once it's gone, it's gone. You know, we've extracted what we can and thrown the packet away. So the ability to go back and actually either recreate the session or at least dig in a little bit more is, you know, with the right use cases, just extremely valuable.
Very good. And so my last couple of slides really, you know, I wanted to kind of re-emphasize this whole concept of network time machine, you know, the whole concept of smart capture. And again, this goes back to what OU is emphasizing on. You know, what OU is doing, and something that inherent to these two components of Big Switch is the programmability aspect, right? You shouldn't be recording everything, right? The interesting thing would be that you look for anomalies or interesting traffic, interesting events, and then start capturing the flows that you know, are interesting to you, right? So there's a lot of programmability that is built into this overall architecture, where you make that happen. You know, once you look for anomalies, you record those packets, and you know, then you can go to the recorder, you can query those packets, or even replay those packets to a specialized tool, or even send it back to analytics for further analysis and deeper level visibility. So, you know, that's all what I have today. I'm going to turn the control back to Sharon. Thank you very much.
A big thank you to our speakers today. I know we got a ton of great information. We're running really short on time, so we just have time for one quick question. You talked about the 50% CAPEX, the more than 50%, and you said a lot of that was hardware. What's the rest of it, Aaron?
The rest is licensing costs. So I mean, I don't want to. Feel free to reach out to me directly if anyone wants specifics. I don't want to, you know, throw any other vendors on the bus or anything, but basically, you know, there's a hardware cost, but then a lot of the other packet brokers have individual licensing for all of these different things. Whether it be the analytics or the deduplication or, you know, on and on and on. So I guess the software layer on top of the hardware layer was, I guess, makes up the rest of that. But I would say the majority of it was at the hardware layer. Nice thing about, you know, Big Switch is all of that just comes bundled together. So, you know, the management fabric, all of that is all bundled together. The service node is separate, but it's still a lot cheaper than, you know, licensing all these different components that we had to do with our legacy packet broker.
I want to thank you both. We're running short on time, so I'm going to wrap up. We make it easy for you to get started with Big Switch Solutions. There are several resources you can download or watch that will give you a tour of our products, either on our website or our YouTube channel. Just visit us at bigswitch.com. If you, in your handouts, you'll see live links that you can click to access any of these resources that we've listed here, as well as resources from our panel. With BSN Labs, you can experience Big Switch Network's bare metal SDN solutions firsthand from the comfort of your PC. We believe there is no better way to learn about a product or technology than to take it for a test drive. For free online real-time access to our SDN Fabrics products, just visit us at labs.bigswitch.com. You can also download the handout, and there's a live link for you to access as well. We'd also like to invite you to join us for our next webinar, Container Networking, Mesosphere, and Big Switch. It's on Thursday, May 31st at 10 a.m. Pacific time. Please watch your email for a registration link, or go to our website and you can register at bigswitch.com/webinars. I want to thank our panelists, and I want everybody to have a wonderful rest of their day and a great holiday weekend.